So hello everyone, good evening to all of you. So as I tell you that in this session, this is our first session. So first we will start with the introduction of ourselves. So let me first introduce about myself. So I am Pratyush Kumar, who is recently completed PhD from IIT Bombay, and I have my complete work is on OpenFOAM. So in my PhD, during my PhD, I have done some development level coding in OpenFOAM. I have developed the solver. I have developed the SRC folder library for the porous media, and I have also developed the different boundary condition. That boundary condition involved the multi-region boundary condition, and also I have developed a boundary condition for the turbulent model. So that is where I have experience of the development level programming in OpenFOAM. And I am planning this workshop from a longer time. So when I was in fourth year in my PhD, that time I have planned with my colleagues who is also doing their work in OpenFOAM, and I have planned during fourth year, but due to the some academic situation and due to the some busy schedule, I could not able to start this workshop. Although apart from this programming workshop, I have conducted some of the basic and foundation level of the workshop in IIT Bombay, and in also I have conducted one workshop, online workshop, that is for only 4 hours. So one day I conducted a basic level of how to run a test case in OpenFOAM, and other than this, I have also conducted a one workshop on the OpenFOAM programming. So before starting the sessions, I would like that please give your introductions. Everyone, please open your camera and give a brief introduction about yourself, where you are doing a PhD or whether you are working in the industry, and some of the your level in the OpenFOAM or in your level in the programming level, means how you are compatible with the C++, and some of the your research problem that you are working on. So just take 2 or 3 minutes and introduce about yourself, and then we can start with the these sessions. So you can start from maybe Rupak. You can start from your, and then other guy can start. Just open the camera and give your brief. Rupak, can you hear me? Hello?
Yeah.
Yes.
Am I audible?
Yes, you are audible.
Hi, Pratyush. How are you?
Yeah, I am good.
Hello, everyone. I'm Rupak Kumar, and presently I have completed my PhD in mechanical and industrial engineering from IIT Roorkee last year, and currently I am a postdoc. And I am working on hydrodynamic cavitation at the moment, and I'm using OpenFOAM from my from first year of my PhD. But in programming, I would say I'm still beginner. But overall, I know about BAS and I know how to use the things. But programming, as I said, I'm still a beginner. That's it.
Okay. So Rupak, you have what problem you worked in your PhD?
I have worked on this three-phase flows, multi-phase flows.
Okay, great. So you have just started with the some simulations, not any development kind of thing.
Here and there, I've tried to modify, like changing the function objects or maybe
Okay.
introduce, yeah, like that.
Got it. Okay. So another person, maybe Akshay, you can start.
Uh, Hi, sir. My name is Akshay. Sorry, I'm not able to use camera because in Asus ROG laptops camera don't come. So that's why my screen, my camera is not visible. I mean, my face is not visible. So I just completed my MTech in in thermofluid engineering from IIT Roper, and my MTech thesis was on the phase change materials. I mean, the phase change material filled heat sinks, which are that are generally used for the cooling of electronic chips. So that was my project. So I worked on OpenFOAM and and modified the solver, which was buoyant pimple foam. So that was my work.
Okay, okay.
Yes, sir.
So for that problem, you used OpenFOAM.
Yes, sir. For that problem, I used OpenFOAM.
So
I
you have
mean,
done
the
any
already
development or just you have used means standard solver that is available in OpenFOAM?
no, sir. Standard solver was already there, buoyant pimple foam, but I modified it. I mean,
Okay,
depending
okay.
on
You have done
the
some little
uh,
bit modification also.
yes, sir.
Yeah,
And
great.
I also learned C++ during that time. I am also following your channel for a long time.
Yeah,
So
yeah.
I got an idea from there.
Okay, okay.
Yes, sir.
Great. Acha. Yeah, Jamshid Muradi, you can give your introduction.
Yes, hello everyone. I'm Jamshid Moradi. I'm a
You can
PhD
turn on
student
your
from
camera if possible.
there is an issue with my camera. I try
Okay,
to
okay.
fix it for the next
Okay,
sessions.
okay, okay.
Uh,
It's no problem.
yes, I'm a PhD student at the University of Oulu in Finland, and
Yes.
my research is greatly focused on active matter in drug delivery and biological systems and how they affect the rheology of the fluid flow. It's maybe it's we're gonna to simulate multi-scale simulations based on our further development.
Mhm.
And my knowledge about OpenFOAM is also I know how to develop a library and then compile it,
Okay, okay.
something like that. Yes.
Okay. So means you have also means you have already developed a library, you know, but what you are planning to develop in future.
Not too much, but I am
Okay.
trying to do some similar
Okay.
tasks, but I have
Subsystem.
developed a simple library before.
Okay. So means which solvers or which model you have used till now?
You mean the solver?
No, I mean to say like which kind of problem is like multi-region or multi-phase.
It's kind of uh, multi-phase, Lagrangian
Okay,
multi-phase simulation.
okay, 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 great.
Yes.
Uh, Anirban, you can introduce yourself.
So I'm audible.
Yeah, you are audible.
Hello everyone. I am Anirban Dash from School of Energy Science and Engineering, IIT Kharagpur. I am currently working on conjugate heat transfer problem using CHT multi-region form solver. I am currently working on phase change material and how its thermal conductivity can be improved with help of fins.
Okay,
I have already run some simulations on at basic levels using the system intelligent from software.
okay, okay. So you have using the multi-region default solver, and
Yeah,
you are
yeah, yeah,
solving some complex problem using the
yeah,
multi-region solver.
yeah, yeah, yeah.
Great. So you have not done any development.
No, 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 not that much, not that much.
Okay, okay, great. And also Nikhil, you can introduce yourself. So Nikhil is one of the mentor. So you can introduce yourself. Hello, Nikhil. Okay. Maybe Gyan, you can introduce yourself. Gyan Bhaskar Rao. Hello, Gyan. Are you? Okay, sorry, he's not there. So okay, so means during the session, I request everyone to mute your mic, and if you have any question, you can raise your hand or you can type in the chat. And today is the basic level of OpenFOAM. So we will start with the introduction only, and then means as I have described the complete course structure. So let me go to the course structure. One minute, someone is trying to join the. So first we will start with the beginner level, where I am going to means introduce about the OpenFOAM and also about the coding level of programming. So basically, if you find the OpenFOAM course structure or OpenFOAM workshop structure in other online any courses, so their structure is little bit different from mine structure. So while I was learning OpenFOAM during my PhD, so I found that if we go in a way that in one side we are learning OpenFOAM, and another side if you are learning the C++ basics, and if we go parallelly, then our understanding of the programming will be completely means completely different, and in that way we will understand the deep programming structure of the OpenFOAM. So means for example, if you want to develop any Android app, and if you don't know anything about the Android app or anything about any applications, then it is better to first understand the coding and then parallelly how these apps are working. And both, if you are learning it parallelly, and after in that scenario, if you are going to develop any Android app, then it will be more effective compared to the if you learn means first you learn that how this app is working. So that is why I have designed this course. So that means we are going to parallelly doing the both OpenFOAM, and parallelly we are going to do the programming course also. So that is why today just we are going to understand about the basics of OpenFOAM. So where we are going to understand how how this OpenFOAM folder structure works, and some of the Linux command, and some of the test case. We are going to run our first test case, and I will give you some exercises. I know that many of you are already at an advanced level, who are already running some programs in OpenFOAM. But since this is the course structure, so we have to keep some patience up to when we are going to the foundation level. So this first 2 weeks, we are going to just introduce about the basics of the OpenFOAM or basics of the C++. And after that, we are going to do up to from the foundation level, we are going to have some idea about the how this FVM is working in the OpenFOAM, and maybe how this meshing structure means arranged in the OpenFOAM. That aspects we are going to discuss in the week 3. Okay, so this is the content of the week 3, and after that we will start about the developing the OpenFOAM programming. So first we will start developing the solvers, and we will also discuss how this dictionary dimension type and field is working in OpenFOAM. And this is the most advanced topic, that is how this doxygen and object registry can be used in OpenFOAM to model a new solver. Okay, so as you already know that OpenFOAM completely works on the object registry. Okay, so it always create one object, whatever things you are specifying as a variable. So that is where this object registry is important. So this complete aspects we are going to discuss in week 4, and after that week 5 is about the solver modification, and also we are going to code the simple form solver from the basics, where we will going to discuss about the algorithm of the simple form, as well as one side we are going to follow the algorithm and another side we are going to do the coding. Okay, so we will create the object of the mesh, and then how that object of the mesh can be used to do the different means Navier-Stokes equation, and also how this pressure velocity coupling is done, that we are going to see here. Okay, and then best, since we are now aware of the simple form coding, so now the coding aspects of the simple form and one of the multi-phase solver, that is interform, we are going to decode. We are not going to code the simple form or the interform. We are going to use the codes of the simple form and interform, and we are going to decode that code, and we are going to understand it how this two solvers is working. So interform, there is a Muse kind of algorithm is used to capture the phase interference. That algorithm we are also going to see in the more details. And of course, now once you understand the simple form and the pimple form and entered form in algorithm, now this is very easy task for you to develop a new solver. So that we will also do. And after that, we are going to understand the boundary conditions. So at the foundation level, we are going to just understand that how this interfields and the boundary fields are correlated to each other, and how this interfields is handling the boundary patches, and how you can means connect between the means interfield cells with the boundary field cells. That things we are going to see here. We are not going to develop any boundary condition here. First we will try to understand these things, and then after that we will go to programming layer. So one sessions we are going to completely work on the boundary condition and the turbulent flow. Okay, so this complete session is all about the turbulent flow and the boundary conditions. So maybe one or two boundary conditions we are going to develop here, and rest of sessions is on the turbulent flow. Okay, so one of our mentor, that is the Gyan Bhaskar Rao, he is already working his complete PhD on the turbulent flow. So he is going to take these sessions about the turbulent flow, and means up to this level you are already some master in the programming. So these 3 or 4 exercises will be not much difficult for you. It will take means not much time, but means approximately 1 hour will be take for the transport model, and similarly for the thermophysical model and the utilities. And these are the some means research topic, that is the compressible flow and dynamic mesh movement. And again, this session is going to be taken by one of the mentors. Someone is joining. Okay, and from week 6 to 10 we are means having sorry, from week 9 and 10 we will completely most of the time going to focus on your research problem. So see, from the foundation level we will start to discussing your project problem. So weekly we are going to have some discussions about your research problem, and based on our expertise, that is the mentors, we will assign one of the mentors to your project problem. He is going to help you out throughout the given week up to week 10. So like if you have any problem related to porous media, packed bed, or multi-region, then I am going to be your mentor. If you have any multi-phase problem, then Nikhil is going to be your mentor. Similarly, you have a turbulence problem, then Gyan Bhaskar Rao is going to be mentor with you. So this from the foundation level, we are going to have one mentor for your problem, and we will completely going to focus on your project work from week 9 and week 10. Okay, so these are the some advanced topic. If you want to join, you can join any of the means advanced topic. Like if I am going to, if anyone has some porous media or multi-lesion solver, then I am going to take the sessions. But if someone wants to join that session, you are also welcome. And similarly, FSI or dynamic mesh movement is taken by the Abhishek. So if someone wants to be in that session, you are welcome. But this 2 weeks is completely related to your project problem. Okay, so this is complete syllabus for this means comprehensive workshop. and today there is a first session. So let's start with the OpenFOAM. Okay, so as I told that I am Pratyush Kumar and I completed PhD from IIT Bombay. So let me first show you that some of the Linux command in on my terminal. So you can, if you want, you can also try with me. Okay, so this is a terminal that you will open on your system if you are using the WSL, and if you are using the Ubuntu, then you can also open the terminal. Okay, so if it types OF6, that means it has created the OpenFOAM 6 environment. Okay, and if you want to check whether this environment has been created or not, so wait a minute, I have to add someone. Okay, so if I type OF6, it has already created OpenFOAM 6 environment. If you want to check whether your means OpenFOAM has been correctly installed or not, you can just type open simple foam help. So it is going to show you complete instructions about the simple foam. Okay, so how you can use the simple foam? It is going to give you a list of the instructions. Okay, you can do with any solver, any kind of solvers that has been already installed in your OpenFOAM. You can do with any kind of solver, and it is showing like this. Then it means that OpenFOAM has been correctly installed. Now here you are seeing the version, that is the, like if you are using the which kind of version of the OpenFOAM, that you can see here. For example, I am using the OpenFOAM 6 version. Okay. Now if you want to know that what are the different environment variable related to the Linux, you can type env. Okay, so these are the different environment variable, okay, that is related to the your Ubuntu or the Linux. Okay, now here some of the commands you can see relevant to the OpenFOAM. Okay, so like this foam solver, foam x libbin, this different foam related command you can see only when OpenFOAM environment has been created. Okay, so if I open the another terminal, if I open another terminal, if I type env, so you can see here that any environment related to OpenFOAM is not listed here. Okay, so only when you type OpenFOAM 6 or only when OpenFOAM has environment has been created, then only you are going to see the environment related to the OpenFOAM. Now, if you want to see all the list of the foam environment, then you have to use this pipeline command. So in Linux, this pipeline command is used to connect two commands. For example, if you have command 1 and if you have command 2, and if you want to connect these two commands, then you can use the pipeline. Okay. Well, this grep is one of the command in Linux that can be used to list the all the commands. And if you want to find that what are the commands that environment has the foam only, foam variable is there, then you can use this kind of the command. Okay, so what I mean to say that, so if I type env and if I use the pipeline and if I use grep and this foam, and you can see here that all the commands related to the all the environment related to the foam you can find here. Okay, so for example, if you want to go to the foam tutorial, then you can just use this variable. You don't need to type this long directory command. You can use just foam tutorial. Similarly, for the foam run, you can use this foam run variable. Similarly, if you want to go to the application, then you can use the foam app, and similarly for the solver. And these are the different environment that is related to the foam. Okay, so these are the some of the environment, some of the ones that is going to be useful when you want to means fast your programming skill. Then these are the commands that is going to be required. Okay, now you already aware of this cd command. So if you want to change the directory, so for example, if I want to go in one of the any folder, okay, suppose I want to go to the sys OpenFOAM folder, then I can use the cd means change directory, and I can type the OpenFOAM, and you can see here that here I am in the folder of the OpenFOAM. So this cd command means if you want to change the directory. Okay, if you want to print something on the terminal, then you can use the echo command. That is the very simple. So this is one of the command that you can use for the printing on the screen. Sometimes it happens that you don't aware that in which folder or in which directory you are currently working. In that scenario, you can use this pwd command, so that you can know that in which directory you are currently working. Okay, so pwd means present working directory. So that command is useful when you want to know that in which directory you are working here. Okay, so this mkdir commands that is used to create one folder here. Okay, so first let's try to first I means I hope that everyone is currently created the OpenFOAM environment in your terminal. Okay, if you have not created environment OpenFOAM, then you can type the OpenFOAM 6, and in that way you are now OpenFOAM 6 environment has been created. Now we are going to go to this run folder. Okay, so we are going to work in Jamshid. We have 2 sessions every week, like Friday and Saturday, 2 hour sessions every week. So like if you want to go to the foam run, then we can type cd foam run. Okay, so here we are currently in the run folder. Okay, so you can see, you can type pwd, that is going to show you that we are working in the means run folder currently. Okay, now if you want to create one folder, that is one directory that is related to this current tutorial, so you can type mkdir. Mkdir means make a new directory, and maybe we can give a one name, week 1 day 1. So we want to create one directory, that is the week 01 and day 01. Okay, so this make directory you can use to create this folder. Okay, so now if you list, you can see here that one folder has been created, that is the week 01 and day 01. Okay, so everyone please go to the run folder and type this mkdir command and create one folder, that is the week 01 and day 01. And if you have any issue, then you can just type in the comment, and one of the mentor is going to help you out. Okay, now we can again change this folder, and we can land into this folder, that is the week 01 and day 01. Okay, so we are now in that folder, that is that we have created. Okay, so this mkdir and ls command, I think you are already aware. Okay, so this ls command is used to list a different directory present in that folder. Control, if you press the control L, you will clear the screen. Okay, Control L is used to clear the screen. Suppose this screen is completely full, then you can press the Control L. That is going to clear the complete screen. Okay, and if you want to list that what are the different other directory is present in the current folder, that is the present working directory, then you can use the ls command. Okay, so currently we have not created any folder, that is why you can see that there is no any folder showing on the terminal. If you want to go to the one folder back, then you can type cd and double dot. Cd means change directly. You want to go to the back, that is why I am putting the double dot. Okay, so now you can see here that earlier we were in week 01 and day 01 folder, but now we were in the run folder. Okay, now if I type ls, now you can see here that different directory is shown here. Okay, so if you want to list the complete directory that is present in the present folder, then you can use the ls command. Okay, and if you want to go to the any of this listed directory, you can use the cd command and the name of that folder. Okay, so these are the directory. This touch command is very useful if you are using the WSL. So WSL environment if you are using, then touch command is very useful. You can create any kind of file using the touch command. Okay, suppose we were in, let's go to the week 01 folder, and you can see here that currently there is no any folder present here. Suppose I want to create one text file, then I can give the text extension .txt, and I can use the touch command. So using this touch command, I can create any kind of extension file in that present folder. Okay, so if I type enter, then you can see here that there is a txt folder, that is the file.txt. You can also use any kind of extension, like if I want to use the csv folder, csv kind of the folder I want to create, or csv kind of the file I want to create, I can use the touch file one.csv. So now you can see here that there is two folder, one is the .csv extension and another is the .txt extension. You can also create the Python kind of extension. So any kind of the extension file you can create using the touch command. So now you can see here that there is one Python kind of the extension is present. So it is useful if you are using the WSL kind of the environment, then you need to create one .foam kind of extension to use the post processing. If you are going to do the post processing using the PyraView in the Windows kind of environment, then you always need to create a .foam kind of extension to visualize that file, that folder. So that is why this touch command is very important. And when we will do a test case, then I will going to show you that how this touch command is going to be useful for you. So these are the some command related to the Linux or Ubuntu. These are the exercise I have means attached here. Just try to do by yourself. Okay. This another examples I have given you that is going to require the cd, pwd, mkdir, ls and touch command. Using this different Linux command, you can do this exercise, and please try to complete these exercises. And these are the references, all the references I have taken from this. See, there are a number of the Linux command or Ubuntu command that I can list here, but I have just listed only those commands which are going to require during the workshop or during this comprehensive workshop. These are the most important Linux or Ubuntu commands that you need to practice. Okay. There are a number of number of things are there, like you can use the Beam kind of editor. That is also going to enhance your programming skill. Now there are different level of program that, as you told you, that beginner, intermediate and advanced. I think the beginner level are only going to get something benefit from this workshop, this today's session. Rest are thinking that मुझे क्या मिल रहा है, like I am already expert in these things. But keep patience, you are going to also get benefited from today's session and also tomorrow's sessions. So now let me introduce about the OpenFOAM. Okay, so I think who are joining here already know about that what is the CFD. Okay, so CFD is used to solve the fluid flow, heat transfer and associated phenomenon such as the chemical reaction. So you may all aware that this Navier-Stokes equation, that is the continuity equation and the momentum equation, that is one of the one of the problem that is not solved by the analytical approach. In such scenario, this numerical kind of the approach is preferred, and that is where the CFD comes to. So when you try to solve the fluid dynamics using the computational or numerical approaches, then that is where this computational fluid dynamics comes into the pictures. Okay, now there are generally three equations is being solved, that is the mass conservation, momentum conservation, and sometimes energy conservation is also required if you are solving the heat transfer problem. Okay, generally in in fluid dynamics, then only this mass and momentum is being solved, and because these two equations are coupled to each other, so we cannot avoid the momentum or mass. You cannot solve the explicitly one of these two equations. But if you are also introducing energy, then this energy conservation is also solved. And sometimes there will be maybe species transport equations or the reaction mechanism involves. So there may be 4 or 5 equations you are solving using the this numerical approaches. And OpenFOAM has all this kind of solvers where you can find the reaction mechanism or the energy conservation. So there are some standard solvers already available in OpenFOAM. Okay, now why OpenFOAM is environment or OpenFOAM should be preferred over the commercial software? So there are some advantages and disadvantages. So since I am taking the classes on the OpenFOAM, so I am not going to discuss about the disadvantage. But sorry, not going to discuss about the disadvantage. But advantages are that commercial software are generally the paid license. And if all aware about how much cost if you are going to use the NCs or other commercial software, but instead of those commercial software, OpenFOAM is a free of cost. Okay, so I think that this OpenFOAM should be preferred in the, at least in the academia or for research problem. OpenFOAM should be preferred over the commercial software. Commercial software is made for the Windows, but it is for the Linux. OpenFOAM is made for the Linux kind of the environment, but using a WSL kind of the environment, we can also now use the OpenFOAM into the Windows. Okay. Now there are many other companies also who are trying to make the OpenFOAM as a GUI environment. So, for example, I can give you one company, that is the AirShaper, which is explicitly made for the aerodynamics kind of problem, and they are completely using the OpenFOAM solvers or OpenFOAM environment, but they have made a beautiful GUI kind of software, and you can just create mesh, and you can just on one click you can find out the solution for the aerodynamic kind of aerodynamic kind of the problem. So there are many companies, they are utilizing the OpenFOAM environment and they are making it GUI based software. Commercial software are the means closed source, and this is the open source. Okay, that you already aware of this. And generally this commercial software is used by the button button kind of the engineers. They just want to they just know what button should be pressed after what task. But in OpenFOAM you should know the basics of the solvers. That is when you can use the OpenFOAM. Okay, so that is why this many industries in India, I'm not sure about the Europe or other countries, but mainly in India, generally industries are preferring the commercial software because they generally hire the MTech or BTech students, and MTech and BTech students not much idea about the background of the what kind of equation they are solving and what kind of the meshing is required. That is why generally industry prefer the commercial software. But this scenario is now changing, and especially in foreign countries now, even industries are shifting towards the OpenFOAM. Okay, in India also, like Adani kind of, under Adani company, another company, now they are developing a R&D department to use the OpenFOAM kind of environment. Now, why OpenFOAM should be preferred? Okay, so generally this commercial software, the full form of CFD is said that colored fluid dynamics, because if you give any problem to this commercial software, they are going to give you a one very beautiful colored picture. Okay, no idea that what is what is physics, whether physics is correctly solved or not, but they are absolutely going to give you one colored picture. But in OpenFOAM, if you are trying to solve without knowing the physics, then you are not going to get a good picture. Okay, you are going to get see on the terminal that the solution is incorrect, or some incorrect inaccurate problems you are going to see on the terminal, because in OpenFOAM you need to know the computational fluid dynamics. Only then you can going to solve the equations. So these are the some reasons why I think that OpenFOAM should be preferred over the commercial software, and that is the way I think you are also here to learn the OpenFOAM. Now, sometime it happens that if students start learning the CFD, just directly go to the CFD software. They don't know about the fundamental of CFD, fluid mechanics, and mathematics. Okay, so that is not also going to happen in the workshops. We are also going to take some of the sessions on the CFD basics, hopefully in the first week of the fundamental series. But we are going to definitely take one sessions on the CFD basics, where you are going to know about the fluid mechanics and the fundamentals of the CFDs. Okay, so what this FOAM standard stands for? So FOAM stands for the fluid operation and manipulations. Okay, so generally OpenFOAM works on the fields. We always, if you see the create field.ts folder, so we always create one field in OpenFOAM. Okay, and that field is associated with the meshes, and we discretizes those fields. We do the interpolations, we solve the equations of states, and we do the we of course we solve the matrices and we store the matrix storage formats. So that is all about the FOAM. That FOAM stands for the field operation and manipulations. We always do the operation on the field, and we do the manipulations. It might be a little bit confusing for you, but once we go to the advanced level, then this term, that is the field operation and manipulation, we'll going to correctly understand this term. Okay, so don't worry about at this level. Now, speaking of the one of the developer of the OpenFOAM, in his words, OpenFOAM is the excellent piece of the C++ and software engineering, decent piece of the CFD code, and I agree with this statement. Why I want to say that? So if you want to solve any kind of the problems where it involves the partial differential equations, or means where you are going to solve some of the governing equations, you can use the OpenFOAM environment. So any kind of the engineering problems, you have some equations and you want to solve that equations, you can use the OpenFOAM environment. Okay, it does not need to have a CFD problem. So that is, I think that is where this statement is correct, that any kind of this governing equations, any kind of the differential equation or the partial differential equation, you can solve the OpenFOAM. And that is why in one of the session, one of the workshops, we are going to solve a one problem that you used to solve in your 12th level BTech, 12th level while you were preparing for the J exam. So like a falling ball from a height, we used to solve differential equations. That problem we are going to solve using the OpenFOAM. That is completely different from the CFD code. So that is why I agree. I sometimes also suggest that if someone is doing the in-house coding, they should also use this OpenFOAM environment, and they should create a mesh, and from creating the different mesh points or mesh edges, using that points and edges, they should create their own in-house using the OpenFOAM. That does not need to be use the OpenFOAM standard solver. So that is why I think this statement is correct, and he is one of the developer of the OpenFOAM. Now let's see the OpenFOAM file structure and see different. We are going to after that see the test case structure. So if you open this OpenFOAM directory, okay. So let me just go to the terminal. So currently we are here, means that folder that I have created. So if you want to go to the working directory, so this is command, that is WM project directory, that directly let you land in the means OpenFOAM where you have installed the OpenFOAM. Okay. So let me type this on the okay. So now you can see here that we are in the OpenFOAM 6 directory. So while you are doing the installation, you might have come across this line, that is the CD WM project directory. So that is going to land you in the folder where you have installed the OpenFOAM 6. Okay. So if you suppose you have done installation using the by default command, like someone might have installed using this sudo apt install OpenFOAM. And if you don't know that where OpenFOAM is installed, then you can use this command cd wm project directory, from where there you can know that in which folder you have installed the OpenFOAM. For example, you can see that we have installed the in the home folder of the my Ubuntu. Okay, so that is where I have installed my OpenFOAM 6. Okay, and if you want to know that what are the structure of the OpenFOAM, so you can see here that this is the structure. First there is one allmake command, then applications, allmake command, then there is application folder, then there is a bin folder, then is a doc folder, etc folder, platform folder, src folder, test folders, and tutorial folders. Okay, so while you are going to install the OpenFOAM, as you know that we have to press this command all wmake and -j and 4. So if you have followed the instructions, that link I have shared in the group, then you have used this command allmake -j and 4. So this is where this you are using this allmake script. So there is a script written in this text file, and that script you are using for installing the OpenFOAM. And -j4 means you want to use the four cores from your system to this installation problem. So if you not type this -j4, still it is going to do the installation, and it is going to only use one core for doing the installation process. Okay, so that all wmake you are going to find in every tutorial folder. Okay, so if you go to the tutorial folders, sorry, if you go to the application folder, and if you go to the any solver, oh, I think there is I need to find out this allmake. Okay, so leave it for now. I will tell you about allmake command and allmake. So if I open this allmake command, so you can use any text editor. So I am going to use the vim edit text editor, but if you want to open any of the folders from the installed OpenFOAM, so you can go to the Ubuntu, you can go to the home, or And if you want to open any of the text file, suppose you want to use this, open this all make text file, you can either use any of the text editor that you have installed, like Genie or Notepad. Okay. So this way you can means open the any text editor. Otherwise, you can use the Vim text editor. Okay, so parallelly, I am going to use the Vim text editor, and I am going to just tell you that what sorts of instruction I am using on the screen. Okay, so if you don't have means Vim editor, then you can use this directly open the text file. Okay, these are the different text file. For example, this WPN, this is also a text file, and you can use any of the editors, like you can use the Genie, Notepad, or Notepad C++, any kind of the editor you can use parallelly, and you can open this text file. Okay, and from here you can do the editing if it is going to require. Okay, so the benefit of using the text editor, that it is going to show you that how this means different sets of the C++ should be followed. For example, if I here you can see that it is showing that this colon should be closed here. Similarly, this bracket should be closed here. So this set of the instruction is followed in the Genie editor by default. So that is why I would suggest that you should means install this Genie editor in your system and try to use the Genie editor for the text editing. Okay. So means the compilation file is the WALL-make that I've already told, and the most of the folders that we are going to use, that is the application, this doc folder, src folder, and tutorials folder. Okay, so if I open this OpenFOAM environment, so there are different folders available. So we are going to work on the application folder, this doc folder, src folder, and tutorial folder. Okay, so the rest is not used for us. Okay, so in application folder, there is a different kind of the solvers. So these are the different kind of solvers. We will come across these solvers and what is the capability of the solvers in the later week sessions. But for now, you should know that these are the different solvers available in the OpenFOAM. Okay. Now here different test cases are there. So if you want to learn basics of the different object related to the OpenFOAM, okay, so there are different objects of the OpenFOAM. If you want to know about those objects, so you can just go through this different tests of the OpenFOAM, and you can understand about the different objects created in the OpenFOAM. Okay, what I mean to say that, suppose you want to know about how this sorting is done in OpenFOAM. Sorting means that arranging a different numbers in a ascending and descending orders, or not only numbers, you can say that arranging a different variables in the ascending or descending orders. So if you want to know about how this sorting is being done in OpenFOAM, you can just copy this test case from here to your working directory. You can just follow the instructions. Okay, so different object definition has been given in this test folder. So this is the very good start where if you want to learn the programming of the OpenFOAM. Okay, you have different sets of the input output. You want to learn about how this input and output instructions are given, you can just open this .c file, and you can just understand that how this different input and output of the string is being done in OpenFOAM. So you can start from here and you can learn about the programming skills of the OpenFOAM using this test folder. Okay, so that is why this solver is also important for you. Test folder is also important for you, and utilities. So different post processing or pre processing utilities are given in the utilities here. Okay, so we are going to also develop a different utility from taking one examples from here, and we will develop one of our utility. So there are different parallel processing utility, post processing utility, and pre processing utility, and the other thermophysical related utilities are available here. Okay, for example, some of the utility you might have aware while you might have done during your test case. Suppose this set field, you already know that this set field is used to set field in a given number of cells. So if you want to set number of cells as a different value, then this set field command is used. So that is where this set field has been coded. So this is the pre-processing utility. Similarly, there are some post-processing utility. Okay. And some miscellaneous kind of utilities are there. And this meshing, like we used to do means meshing kind of things, then this different utilities you are going to use, like block mesh you use for creating the mesh using the blocks mesh dict kind of dictionary. You also use the snappy hex mesh. We also use the foam mesh. So this different kind of the utilities are given here. Okay, so I am going to also decode the snappy hex mesh coding here. Okay, in one of the tutorial we are also going to decode the coding of this snappy hex mesh. So how this handles the mesh background mesh and how it creates the background mesh into the snappy mesh, how it snaps out the STL file attached with the background mesh. These things we are going to understand while we are going to decode the coding of the snappy hex mesh. So that is why this application folder is important for us, and these three folders is important. But this solver is also important, test is also important, and utilities is also important for us. Docs, if you want to use the doxygen, then this doxygen is also important. Means you can means for doxygen you can either use this HTML file. Okay, otherwise you can just directly go to the doxygen of the on the terminal. So you can just type OpenFOAM 6 doxygen, and you can usually go to that doxygen, and you can understand the coding of the OpenFOAM. Okay, different classes are there, different names. So when we are going to understand the object registry, then these things are going to be required. How we are going to use means a number of times how this doxygen is being used, that we are going to see how different namespaces are created in OpenFOAM. So most of the namespaces you are going to find inside the foam namespace. So these are the different classes or namespaces are being created. Okay, so we are going to see how this doxygen is useful for you in one of the tutorial. So not worry about this. And this two guide user form guide that you can find in the doc folder. So this is just for the documentation of the OpenFOAM. So if you want to learn OpenFOAM programming or the how to use the OpenFOAM test cases, then this doxygen is the basic level of understanding you are going to get. Then after that, you are going to understand this SRC folder. So when we are going to understand the turbulence model or compressible flow, or when we are going to create our transport models, then this folder is important here. Okay. So like solvers have some linked library. So solvers, you are going to just solve the governing equations. So what are the different schemes you are going to use? What are the different means how the different variables are going to define, how the different dimensional scalars are being defined. That all is sorts of in the SRC folder. Okay, that is why OpenFOAM is known as the library based C++ of software. So because OpenFOAM works on the different libraries. So when we are means everything, what are the sets of instructions given in the C source file, it always linked the sum of the libraries, and that library is created in the SRC folder. Okay, so when you are going to develop a SRC, then you need to become some of the means programming level of the skills is required for you. Okay, so the boundary condition is also handled by the SRC. Different physical models is also handled by the SRC folder. Transport models like different viscosity models is also handled by the this SRC folder or the OpenFOAM. Okay, so this all things we are going to understand. Object registry is also handled by the OpenFOAM. Meshing is also handled by the OpenFOAM. So everything means you can say that the heart of the OpenFOAM is the SRC folder. Okay, so with that we are going to see while we are going to understand the advanced level of programming. So as I told you, this is important for us, this is important for us, this SRC is important for us, and this again tutorial is very important for us. Okay, so this is the different test cases, different of the test cases is installed already, all given here. Okay, so you can means when you want to either make your new cases, then also you should means copy one test case from here, and based on the given zero constant or the meshing file, you can develop your new cases. Okay, so this is the means basic of the basic idea about how test cases should be arranged in the OpenFOAM. Okay, so this is all about the different folders of the OpenFOAM. Okay, so already told you that the solvers has the source code of the solvers. Okay, so one questions that I want to give you that means whenever you want to work either for the solver or the test case or the means tutorials, don't modify anything in the folder of the OpenFOAM. Okay, so what I want to say that if you want to run a test case from the simple form or ICO form, so as I was saying that if you want to work for any folder, so don't modify anything in the folder related to the OpenFOAM. Okay, so always create your own folder. That is basically means you can create like a run folder, and in that folder you can create means develop your own solver or run a test case. Don't modify the OpenFOAM test case. I have means already once I have done this mistake by mistake means during my PhD, and I have to again reinstall the OpenFOAM, and again I have to install again because there is some issue I have done, and it was always showing the error whenever I was working with that solver. So that is the means whenever you are working with the OpenFOAM, just try to means get means work in your own directly, and when you are going to install or compile a solver, you should compile the solver in your user directly. Okay. So these are already told you that. Speaking of the bin, so the bin is not important for you, but whenever skips like you used to create a app, or you used to create a log file, or you create a any kind of new folder, then these scripts are written in the bin, but we are not going to develop any means any terminal command like foam new app or foam new bin. So that is not important for us, but you should know about these commands. Okay. So these are the different command like foam search, foam new app, foam new boundary condition, foam new function object. So these are the commands when you are going to create a different means file. Like suppose, let me give example, then you can correlate here. So suppose I am going to run folder. Suppose I am here and I want to create one solver. Suppose I want to create one solver, that is foam new app command is given here, and you can create any kind of solver like my simple home. So if you go here, you can see that it has already created one means app, that is foam new app. Foam new app means you want to create a solver, and you are giving the name of the solver. So it has already created one new solver. Okay. And if you go to that solver, you can you can see that it has already followed the by default structure of the solver. So it has already a make folder, it has already given one .c source file. So these are the commands that is going to be useful if you want to create a different boundary condition, or if you want to create a different utility, or if you want to create different function object. So these different commands that you can use here. Okay. uh, so maybe means when we will going to do the programmings, then you can we are going to use some of these commands like foam clean polymesh, foam clean tutorials. These are the commands that we are going to use the clean the polymesh of the test case. If you want to create the completely test case, then you can use the foam clean tutorial. So don't worry, we are going to use some of the commands here which are going to required during your programming or simulation lectures or tutorials. Those commands we are going to use from this year. So that is where bin is important, but we are not going to do any development for is related to the bin. Okay, so documentation I have already told, and every environment folder related to the OpenFOAM is available in the etc. Okay, so that is why when we source means OpenFOAM, then we use this etc folder. Okay, because every environment is created here. So what I mean to say that suppose if I go to the base RC of the OpenFOAM, this is the base RC of the complete open Ubuntu. So this is the complete environment related to the Ubuntu. So base RC is means the terminal understand only the base RC. Okay. So that is everywhere. Everything is related to the Ubuntu environment is given here. So if you go here, you can see here that this is the command that we are using to source the OpenFOAM. So when you type OF6, so when as long as you are going to type the OF6, it is going to source these things. Okay, foam, OpenFOAM 6, etc base RC. So it is going to source this location, and that is why this terminal understand that what is the OpenFOAM or what is the different commands of the related to OpenFOAM. Okay, so you can see that this is the etc where everything is every environment is created related to the OpenFOAM. Every template, every commands, everything is given in the etc of the OpenFOAM 6. So that is only you should know about etc up to this level. And there is also bash RC, which is a means local bash RC for the OpenFOAM. Okay, this bash RC is for the complete Ubuntu environment, but this bash RC is related to the OpenFOAM only. That is the local bash RC. Okay, so when you type Web 6, basically you are creating the local bash RC of the OpenFOAM 6, and that is why this terminal is going to understand the OpenFOAM 6 environment. Okay, so that I have also explained to you. And this platform already means whenever you compile a different solver or libraries, so it creates one app. Okay, so let me go to the folder. Let me show you. If you go to the platform, OpenFOAM 6 platform, and if go to the one of this bin, okay, so you can see here that different utilities given here. Okay, like ChemFoam, ChemKin to foam. So what are the different solvers or what are the different utilities you have created? That is going to create one app, and that app should be present in the bin folder. Okay, so means whenever you created one simple form or my simple form solver, so OpenFOAM creates one app, and that app is located in the bin folder. Okay, so that is where bin is useful. So different library, different SRC, different application or different bin is means located in the platform folder. Okay, but when you going to create your own solver, so that should be not present in the OpenFOAM bin, but there is going to one bin in your user folder. Okay, so here you can see that there is a platform is created, and in that platform you are going to develop your own solver or your own utilities. Okay, so that is why it is said that don't disturb the by default structure of the OpenFOAM. Whenever you are going to create a solver, you are going to create in your own user folder. Okay, and how it is going to be created in your own user folder? When we are going to develop our first solver, then we are going to explain everything. What is the make folder, how this file understand the what source code you want to install or what source code you want to compile, and everything we are going to explain when we are going to develop our own solver, first solver. Okay, so this is related to the platform of the platform folder of the OpenFOAM. Okay, SRC folder I have already told you that everything, field declaration, mesh operation, mesh feature discretization, everything is related to the SRC folder. Okay, apart from means SRC means from you can say that from zero level up to the solver creation or test case development, everything is available in the SRC folder. Okay, so like field operation, means field declaration, field operation, mesh operation, mesh manipulation, everything is available in the SRC folder. So if you want to understand the heart of the OpenFOAM, you should understand how SRC folder works. And this tutorial already told you that the different tutorial cases are available in the OpenFOAM, and we are going to use these test cases or tutorials to develop our own test cases. Okay, so we need to follow the by default structure of the tutorials available in OpenFOAM, and using those by default tutorial cases, we can develop our own test cases based on our problems. Okay, so it will going to tell you that what kind of the folders, how folders should be structured in your OpenFOAM, otherwise it is going to show you error. Okay, so we are going to also follow here. And WMake is important if you want to make your own solver or own library. So all the compilation structure, like how this make folder should contains the file and optional folder, and how this source code should be structured, everything instructions is given in the WMake. Okay, and different relevant rules can be find here, since we are not means in the programming level. So just I am telling you the some basics about the WMake. We are going to understand the WMake, how this WMake works for the solver compilation or the library compilation or the utility compilation, that we are going to understand in the upcoming sessions. Okay, so I think the OpenFOAM directory structure, now you may have some aware about this. Now let's understand the first test case. We are going to solve our first test case using the OpenFOAM environment. we are going to means become some familiar with the OpenFOAM environment or OpenFOAM, how we can run our test cases. Okay. So this is our today's menu, that we are going to take one tutorial from the OpenFOAM tutorial, and we are going to run our first test cases by using the pre-processing simulation, and we will also going to do the post-processing. Okay. So this is the OpenFOAM by default structure. I hope that everyone has now this run folder. So if you typing this form run, then you should enter run of the your own user folder. So my user name is the Pratyush6. So now I am in the my run folder. Similarly, you should run landed in the your own run folder. So I hope everyone in the same page. Raghu, when we will compile our solver, then I can show you that how you can push your solver to the. So what error you are getting? Nikhil, are you here? Means can you hear me, Nikhil? Nikhil, Gyan, are you here in the session? So Nikhil, can you help him out? Can you help this Anirban for creating a run folder? Yes, Anirban, Nikhil will help you out. You can contact him. So if you are not getting this folder like a run folder, you can just type this command. So who are not getting this folder, that is run folder, you can type this mkdir foam run command, and after that you can type cd foam run. So Anirban is yeah, even if you are installed in the root, then if you type this command like mkdir foam run, you will get a run folder in your user case. Anirban, have you solved this error? Okay, so if you are landed here in the run folder, then we can take any test case from OpenFOAM. So for example, in tutorial there we can go to the test incompressible solver, and from here maybe we can take one test case from the this in simple form. Okay, so we can copy this PITS daily test case. So we can use the cp command. Cp means we want to copy, minus r means we want to copy a directory. Okay, and we can go to the home tutorial. So this is the as I told you that there are different variables is already given in the etc of the OpenFOAM, and from that variable we can directly go to the foam tutorial folder of the OpenFOAM. Okay, and we can go to the incompressible, and here in compressible we can go to the simple form, and here we can in simple form we need to copy this PITS daily test. We can copy PITS daily. Okay, so this test case we can copy here, and since we want to copy at the present location, so that is why we need to put a dot here. Okay, so this means that cp means we want to copy, r means we need to copy one directory, and this is the test case that we want to copy, and dot means we want to copy at the present location. Okay, so if I enter here, so you can see that here we have one test case. Sorry, let me copy in the week 01 folder. In that way, it will be easy to. Okay. So in that folder, that is the week 01, day 01, I have copied one test case from the simple form default test case, that is the PITS daily. Now if I go to the PITS daily, and if I go to show you the folder, so there is a 0 folder, constant folder, and system folder. Okay. So if I open in the system, so that is where I have copied. So this PITS daily test case I have copied here, and similar things you are seeing here. So using this cp command, I copied one test case in the this week 01 and day 01 folder. So if I open this folder, you can see here that there are 3 folders. That is the 0 folder, constant folder, and system folder. Now if you want to solve a CFD problem, so what is required to solve a CFD problem? So if you want to solve a CFD problem, there needs to be a meshing or a geometry. Okay, and that geometry is handled by this test case. Okay, that boundary condition, that geometry, and the different meshings, these are being handled by this test case. And what are the different sorts of equations you want to solve in the CFD, that is handled by the solvers. Okay, so these 2 things are important if you want to solve a problem, that is test case and that is the solver. Okay, for example, means if you can relate with, if you want to edit a image. Okay, suppose you have a given image and you want to do some Photoshop, or if you want to edit that image. In that scenario, if you have a one image and you have a one software, okay, so that image is called the test case, and that software that you are using to edit the image is called the solver. So that is why this solver is called the applications, because you are using one app to solve your problem. So image is a one test case and this is the solvers. And how you want to edit the solver, how you want to edit the photos, that is the instructions. Okay, so this different sets of instructions is given in different folders of the OpenFOAM. Like in system, if you go here, you can find out the different schemes, and this is different instructions given related to the time is handled by the control dict. Okay, so for example, from where you want to start, that is given here, and what are the different start time and end time, and what is the delta t, that all sorts of the instructions are given in the control dicts. Since it is the basic level, today is the basic level of the class, so I'm not going to depth in this different start time, start at end time, and different these functions are being used. We were going to understand these different instructions here in more details. So just I'm giving you a brief introduction about the different files or the different text files in the given test case here. So different field variables that is declared in the OpenFOAM, how you are going to discretize, or how you are going to solve, that is that schemes are given in the this FB schemes folder. Okay, so for example, different Laplacians terms given in a governing equation is going to be discretized by using the Gauss linear charactered method. Interpolation schemes are given the linear, grad schemes are given the character. So different schemes are being handled in the FB schemes. Different solution like tolerance value, relaxation value are given in the FB solution. Okay, these are the different relative tolerance. Okay, and what are the residual controls you are giving here, what are the relaxation factors are giving here, that is going to be given in the FB solutions. So these are the sorts of instructions you want to give the test case, that these are the instructions should be followed while solving the equations. This constant folder is important to understand the meshing properties. Okay, So different physical properties or the meshing properties is given in the constant folder. So for example, the transport properties are given in this folder. Okay, so like what are the values of the viscosity and what transport model you are using, means you are using for the viscosity. These instructions are given in the transport properties folder. Similarly, for turbulence, whether you want to solve the turbulence or not, and if you want to solve the turbulence, then what are the model you are going to use for the turbulence, that is given in this folder. For example, here it is solving the turbulence model using the RANS model. And in the RANS model, there are different RANS model is available. In that RANS model, it is using the K epsilon model. So these sorts of instructions are given in the constant folder. And zero folder is related to the initial boundary condition. Okay, so these are the, since it is using the turbulence model, so these are the parameters related to the turbulence model. Okay, and these are the means V and U, that is for the pressure and velocity. So different initial conditions are given in this folder. Okay, so different boundary condition, boundary filter are given like inlet, outlet, upper wall, lower wall, and front end wall. So these different values are the initial condition are given in the zero folder. Okay, so this three structure, this three folder is the basic structure of the OpenFOAM test case. These are the important folder. If you are if you don't have this any of this folder, then you are going to get an error while running a solver. Okay, others more other folder you can find in means advanced kind of the tutorials, but these are the basic structure: zero, constant, and system. Because system is important for the giving the different schemes, time control, as well as the tolerance or relaxation factor. Constant is important because for the meshing and the different physical properties, and zero is important for the initial conditions. So these are the basic requirements if you want to solve any CFD problem. Either you are doing in-house coding or you are using a commercial software. These three folders is going to be required. In OpenFOAM, it is handled in the form of the zero, constant, and system. In other software, you might have a different sets of the requirements. But these are the basic things like physical properties and meshing, initial boundary condition, and the different kind of the means schemes that you want to use, relaxation factor, and time, how you are handling the time. Okay, so that is why we are using the simple case. And since here you can see that block mesh dict is used here in the system, so it is using the block mesh utility of the OpenFOAM. So as I told you that if you go to the OpenFOAM and in the utilities, so there is a different meshing utilities is given. Okay, so in generation, if you want to generate a mesh, then there is a different generation utility for the meshing creating is given here. So out of this utilities, block mesh is being used. Okay, so out of this different mesh utility, we are using the block mesh. And how we came to know that, because there is a one folder in system that is block mesh dictionary is present here, and that is how we know that we can use the block mesh utility to create the meshing. And we are also going to in the means foundation first week, we have a one session on the meshing only. So where we are going to tell you how to create the block mesh, how to use the block mesh for creating a rectangular geometry or a cylindrical geometry. How can you create a wedge kind of the means meshing, that all sorts of the meshing utilities that we are going to discuss in that session. Okay, so to use the block mesh, you can type in the terminal, that is the block mesh. Okay, so now if you now open the constant folder, you can see here that one folder is being created, that is the polymesh. And polymesh, everything's related to the meshing is given, like it is given the what are the different boundary conditions. So if you open the boundary conditions, so you can see here that inlet is given, outlet is given, upper wall is given, lower wall is given, front and back is given. So as soon as you type the block mesh, it has created one polymesh folder, and in polymesh all sorts of the all sort of the meshing related things are arranged in this polymesh folder. So like different faces are given here, different neighbor are given here, different owner are given here, different points are given here. Okay, these different things we are going to understand. Don't worry about for now. We are going to understand everything, how faces are being handled, neighbors are being handled, owner are being handled. These different things we are going to understand. But you should understand that every meshing related things, it is created in the polymesh. Okay. And if you match with the boundary fields here, so this should match here. Okay, so what are the different boundary fields being defined in the constant folder? This should be matched with the this here. Okay, so if you see this boundary, so this inlet, outlet, upper wall, lower wall, front and back, these are the boundary that is created in the constant folder. Similarly, if you open the any field variable, any boundary condition means created in the zero folder, this different boundary conditions should be present here. Otherwise, it is going to show an error. Okay, so this inlet, outlet, upper wall, lower wall, front and back, you can find here. Okay, so every different boundary layers you are going to get error. So suppose you can try here. So if you want to let me make it test. So if you are going to run our solver, simple form. So you can see here that it is saying that cannot find the patch field entry for the inlet. Okay, and where it cannot find, so you can see the location here. It is saying that the folder present in the zero folder, that is the P boundary field, it is not finding entry for the inlet. Okay, so that is why whatever the boundary field is created in the constant folder, inlet, outlet, upper wall, lower wall, okay, that should be defined in every variable, every field in the zero. Otherwise, it is going to show you error. So now we can modify this P and we can type inlet. Okay, so that means that every boundary field should be defined in the zero folder. Then only we can run the solver. Okay, now our all criteria has been fulfilled to run our first test case. We have all the three folders, that is the basic requirements. We have created mesh using the block mesh dict. All the boundary fields has been defined in this zero folder. Different properties is given in this constant folder, and different schemes has been given in this FB scheme, FB solution, and this time, how we want to handle the time, this is given then in the control dict. So these are the basic requirements that is required if you want to run your test case. Okay, so everything has been set up from here. Now you can run simply the simple form. Control L if you want to clear the screen, and you can run the simple form. Okay, so this is going to run. Okay, now it is running the simulation, and you can see here that it is taking the one time step. So if you open the zero control dict, so you can see here that it starts from the 0 and it will go up to the 2000, and the delta t, that is the means delta t, that is the time gap between the this consecutive simulation. So you can see that this is taking 231, 232, 233. So this all time related instructions, it is getting from the this control dict folder. Okay, and if you see, for solving the U field, P field, this smooth solver, GMG solver means solver, this instructions it is getting from the FB solution. So if you open the FB solution, you can see here that for solving the P, it is using the GMG solver, and for solving the U and means other different turbulence related the variable, it is using the smooth solver. So this information it is getting from the FB solution folder. Okay. So now you can see here that it is it gone up to the 288, and after going from time 288, it has been already converged. Okay. So converged means it is reached to the tolerance level. Okay. So the tolerance that we have provided in the FB solution, so it reached up to this tolerance, 1 e to the power minus 5 for the u, 1 e to the minus 6 for the p. So when you open, so you can see here that for the u, this has reached 1 e to the power minus 6, and for uy it has reached up to the 1 e to the power minus 5, and for p also, sorry, it is not showing for the p, that is the final residual. So there are two criteria, that is the relative tolerance, that is 0.1, and tolerance, that is 1 e to the power minus 5. So out of these two, if any of the criteria is fulfilled, it is going to show that the simple solution has been converged. So it has taken around 288 iteration. So if solution will be not converged, then it is going to solve up to the 2000 time step. That is the mentioned in the control dict folder. Okay. So if it is not going to converge into the 288 or any number of the iteration, then it is going to solve up to the 2000. Okay. Otherwise it will converge into the initial state. So this is for the steady state. So you already know that the steady state solver should have the converged solution. So since it is converged after the iteration 288, so it is not going to solve after the 288 iterations. So now I hope everyone has get these three folders, these three time step, that is the 100, 200 and 288. Okay. Now if you want to use the post processing, we can use the touch command, and we can use create one .foam folder. Okay. So this .foam folder should be present here. Since I have created one wrong folder, that is .foam, so I am deleting using this command. So this should be present here if you want to visualize this result. Okay. If you are using the Ubuntu, means you are not using the WSL, then you can by default use the Parafoam. Okay. If you are using the WSL, then you need to use this touch command to create one .foam folder or .foam file. Okay. Now you can open the ParaView from the this search. From search, you can open the Parafoam or ParaView. And we can upload this .foam. Okay. Okay, so this is a case, that is the Pitts Daily, and you can see the converged solution here. So everyone is able to open the test case in the Parafoam or not? Please raise your hand if you are using the WSL. Yes, Muradi, we are going to cover the Snappy XMS, but since this is the first tutorial, that is why I am just covering the simple test case. Don't worry, we are going to cover everything. It means at last you are not going to see anything that we have missed during this comprehensive workshop. So don't worry about at this time. Yes, Rupak, you have any questions? You can type in the chat box if you have any problem. Rupak, you have any questions? Okay. Okay, so this is the environment of the paraview. Okay. This is environment related to paraview, and if you want to go to the last solution, last time frame, then you can press the last frame. This is the converge solution, that is the time step related to 280 watt. Okay, and if you want to change the background, so this background you can see here, that is the gray kind of background. So just you can scroll down here. This panel you can see here on the left side, and you can just disclick this, unclick these things, and here you can change your background. Sorry. So let me just make this background as a white. So this is the background. Okay. Now if you want to change the color, so this color is this might be not okay for everyone. So you can go here, just type here edit color map. Okay, so you might be seeing this like this here in the right side, and here you can have different color option. Okay, you might use this different color option is given, and out of this different by default color option, you can choose any of the given options. Like let me use the rainbow kind of the structure. Okay, so now you might not able to see the text related to this color map, so you can go to the here. Okay, and here you can change it into the black. Okay, and if you want to make it the times font, you can make it times font. You want to increase the size of the font, you can increase the size of the font. Okay, you can also change the orientation. So like here, the orientation of this label is the vertical, you can make it the horizontal. Okay, and if you do the apply and okay, so you can see here that this is the how you can create your own label and own means color map of the given result. Okay, so this is for the u field. Okay, and if you want to save this result, suppose you want to save this result, you can just go to the file and save screenshot. Okay, it will ask that where you want to save. Okay, so one of the problem using this paraview in Windows is that you cannot directly save into the Ubuntu folder. Okay, because it will installed in the C folder. That is why you cannot able to access your C folder, the Ubuntu folder, using this paraview in Windows. But you can save anywhere you want. Okay, suppose I want to save in the desktop, so I can save desktop as the U field, and I want to save as a PNG or different extension of the image you can use. JPG file you can also save, PNG you can save, .tiff file you can save, and even for the BTK you can use the extension. So let me save as a PNG. Okay, so it will save. If I go to the desktop, So you can see here that U field has been stepped here. Okay. Similarly, you can say for the P, this is the basic things. PyraView have also a lots of the options is available here. You can also means even from your side you can take individual colors and you can edit also those colors. You can by default means these levels given here, like there is only kind of the 5 different level of color level is given. You can also edit that also. You can also do the means Python coding. So I will also tell you that how you can use the means automatize the your post processing. Okay, suppose you want to study the parametric study. You have a number of variables. You want to do the means you want to automatize that everything that whatever we have done. Just you can load the test case and it will automatically means do the color map and it will automatically generate one folder, one folder here. That code of instructions we are going to use in the means upcoming sessions. So don't worry about this. This is just a basic class, so that's why I just make you familiar with the PyraView environment. So how you loaded the test case, how you can change the background, okay, how different fields you can load from here, like P, K, epsilon, different field means fields you can, field variables you can load from here. This is for the time step. So if you want to go to the initial time step, you can go from here. Okay. So this is the going to the different time step. If you want to change the color, you can change from here. The different color option is given here. Okay, so these are the different, just a simple things related to the paraform. And advanced level of the paraform we are going to also see. Even I am going to see to tell you that how you can make your own Python coding. So Python coding in paraform or PyraView works as a macros. You can make your own macro and you can use for automatizing your OpenFOAM post processing. Okay. Now the important thing in paraform is that if you want to specifically go to the different patches given here. So for example here, this inlet patch, lower wall patch, outlet wall patch, what upper wall given here, the different patches you can just access from this applying this. Okay. Okay, so now we can see that only this inlet patch is showing here now. Similarly, if I show the outlet patch, so you can see that only inlet and outlet both patch are showing here. Okay, so this is the inlet patch, this is the outlet patch. This is the inlet patch, and similarly this is the outlet patch. So different boundary patches you can visualize from here. Okay, upper wall you can access here. This is upper wall. Similarly, you can go to the front and the back and the lower wall also. So this is different patch information. All the cell region are the different set of the cells that you are going to create. That information you can get from here. So this is the just basic information about the means the PyraView. Okay, we are going to also do the plot. We are also going to create the streamlines using the PyraView only. So I hope up means how to run a test case, what are the different OpenFOAM structure, and what are the different test case structure, and how this paraform can be used for the visualization. Up to this level, you are able to understand. Okay. So I am going to give you some exercises related to the today's class. Okay, sorry. So one thing I also mentioned you, if you remember that I have told you that there are some commands coded in the bins. It's like we have used the foam new app for creating one app. So if you want to create clean this tutorial case, if you want to clean the tutorial case, and if you want to clean the mess, so you have two commands, that is the foam clean. So if you are unclear that which command should be used, just type foam clean and press the tab command. So you can see here that different options has been given here. So tab you can type, which is going to give you set up the instruction command that you can use. So like if I type foam, and you can see that all the commands related to the foam is suggested by the terminal. Okay, so like foam new source, foam new template. So the three commands that is very important from us for us, that is foam clean polymesh, foam clean tutorials, and foam list times. So these three commands is important: foam clean polymesh, foam clean tutorials, and foam list times. Okay, what is the different requirements of these commands? So suppose if you want to just delete these three folders, that is the 100, 200, and 288. Okay, so if you want to just delete this folder, that is the simulation runs after the meshing creator. So when you create the mesh, and after creating the mesh, you run simulation, and you want to just delete those time steps, then this foam list times are important. So if I type tab, so you can see here that it is showing these three folders only, that is 100, 200, and 288. So suppose you want to just delete these three folders. You don't want to you don't want to affect the mesh created in the constant folder. You don't want to change any boundary condition. You don't want to change anything in the system folder. Then you just type this foam list times and put this RM. RM means you want to remove. Okay, so this is going to remove these three folders. You can see that this 300, 200, 288, these three folders has been deleted. Okay, now if you want to clean the tutorials, so either this you can use the foam list time and RM. It is going to remove these three time folders. And if you time this foam clean tutorials, then this foam clean tutorial is going to remove these three folders, as well as it is going to remove the mess folder. Okay, so if you time foam clean tutorials, it is going to clean the test case. Okay, so if you go to the constant, then you can see that there is no any polymesh folder. Okay, so it is going to, this foam list going to remove the all the time step. Foam clean tutorial is going to remove the mesh as well as the time step. And if you want to just remove the polymesh folder, okay, currently there is no block mesh, so let me show you, create the mesh. So now if I go to the, so you can see that there is a polymesh present. So if you just want, you just want to remove the only polymesh, you don't want to touch the test simulation result, then you can just type the foam clean polymesh. Okay, so it is going to only delete this constant polymesh. So this three commands is very important if you want to do the parametric studies. You want to just, sometimes it happens if you just want to remove the test cases, you don't want to change the meshing structure. Sometimes if it happens you just want to remove the polymesh. So this three command line is important, and you should use while running the test cases. Okay, so I think up to this everything is clear. Yeah, all clean command is used, but all clean folder should be present here, ribbon. So if you run here all clean, it is not going to run. If you're going to run all clean, it is going to show you error because there is no any file that is all clean. So all run and all clean is if there should be one text file present here, all run all clean. Only then you can run this all clean command. And this all clean and all suppose means this all clean and all run command, just what are the different instructions we are following while running the simulation, this all instructions are given in this here. So if you open the all clean, you are going to find out there will be some code related to the foam clean tutorial, foam clean polymers. This kind of things are given in that text file. Only then you can use the all clean. Okay. Okay, so I think means I am going to give you some exercises for based on the today instructions, and just try to work on those exercises, and then we are going to work on some other tutorials. So in basics of the OpenFOAM, we are just going to work on the different tutorials. Okay, so this is just a basic tutorial related to the simple form. We are going to do some advanced tutorials in tomorrow class, and please finish the exercises related. I am going to add some exercises related to the terminal command, as well as some related to exercises related to the running a test case simulation. Please finish that exercises, and we will meet you tomorrow at the same time, that is the at 8 p.m. So thank you to all of you for joining.
Pratyush, there are two questions. Pratyush, from Jamshid.
Yeah, I answered Jamshid that we are going to cover the snappy XMS. I have already told you. And yeah, this also I have told you that when we are going to compile a solver, we are going to work on this also. Okay. Yes. So there is no any other questions. Okay. So I will I will request all to please give feedback in the comment box after finishing this tutorial. And if you have any questions, please ask me as many question you ask. You can ask related to the present tutorials. Okay. So maybe we can disconnect now. So thanks to all of you for joining this session.